projectile motion. So let's have an illustration here wherein a baseball player kick the ball to make a home run in the game. So the motion of the ball, as illustrated in the figure, has a track of a curve. This trajectory is what we call projectile motion, and it is always parabolic in shape. So it is a good description of such motion can often be obtained with the assumption that air resistance is absent. Another consideration is the curvature of the Earth is being neglected. So this is the idealized model for projectile motion, that we don't consider the air resistance and the curvature of the Earth. So using the equations presented in the previous topic of the kinematics for constant acceleration in two-dimensional motion, also here in projectile motion, we consider horizontal and vertical parts of the motion separately. So in the horizontal or x direction, the moving object does not slow down in the absence of air resistance. Okay? So these are the following we have to take note dealing with problem in projectile motion. First is the horizontal motion or x direction motion is constant because we don't consider air resistance. So there is no opposition of force in terms of x direction, meaning that v naught x is equal to the final velocity x component. Also, meaning of this is that the x component of the acceleration is equal to 0. In the y direction or vertical direction of the motion, we experience the effect of gravity. So as a result, the y component or the vertical motion is not constant and changing. So again, vertical motion is affected by gravity. And also the y component of the acceleration or ay is the downward acceleration due to gravity, meaning our acceleration in y component is negative 9.821 meter per second squared. So if the path or trajectory of the projectile is near the Earth's surface, the y component acceleration has a magnitude of 9.81 meters per second. Okay, as I said, or 32.2 feet per second for English system. Okay, also we have to take note of this. At the start of the motion, let's say here in the illustration, the ball is kicked by the player at angle of theta. So when we have a given theta and initial velocity, we can solve for initial velocity in y component and also x component. So as it travels in air, Vx is the same with initial velocity. And V naught y is decreasing as it reaches its maximum point. Vx is still the same with V naught x, but Vy here at the maximum height is now equal to 0. And as it goes down, Vx is still equal to V naught x and Vy is increasing, meaning it starts to accelerate. If going upward, it's decelerating, and when it goes downward, it's accelerating because of the influence of the gravity until it reaches its final position wherein Vx is still equal to V naught x. And Vy has another value, of course. Okay. So to understand more about velocity, projectile motion, let's have an example here. So in the figure, the next page or next slide, an airplane moving horizontally with a constant velocity of 150 meters per second at an altitude of 1,050 meters. The direction of the right and upward have been chosen as a positive direction. So take notice, direction to the right and upward have been chosen as a positive direction. The plane released a care package that falls on the ground along a curved trajectory. Ignoring air resistance, determine the time required for the package to hit the ground and find the magnitude v and the directional angle theta of the final velocity vector that the package has just before it strikes the ground. So we have here the illustration. So the right direction is our positive and upward direction is positive also. So we have to take note of this. This point is our origin. So meaning it is 0. Okay. So what our given data or values? We have the x component velocity or initial velocity of 115 meters per second. And for our initial velocity by component, it is equal to 0. Since the motion of the airplane is horizontal and and it does not move vertically, so therefore our initial velocity for y component is 0. And the elevation is, we have here the elevation 1050, negative 1150. Why negative? Because we consider that at the initial point is our origin, Therefore, going downward at to the surface or the ground, we have 1015 meter, which is negative direction. Okay, so first, we are looking for the time it takes for the package to reach the ground. So which equation should we use to solve for time? So we can use equation y minus y naught is equal to v naught y t plus 1 half ay t squared. So the value, substitute the value, we have negative 1050 meter is equal to initial velocity of y component is equal to 0. So plus 1 half, and ay is negative 9.81 meter per second squared times time, which is what we are looking for. So simplify this, we have t squared is equal to 214.07 and square root both sides. Therefore, the time it takes for the package to reach the ground is 14.63 seconds. Okay. For letter B, we are looking for the magnitude and direction of the final velocity. So let's solve first for the final x component of the velocity is equal to the initial x component. Therefore, it's equal to 115 meter per seconds. Okay, so let's solve now for the y component. So we can use the equation final velocity squared is equal to the initial velocity squared plus 2a times the displacement. Then let's substitute for the values. So our initial velocity is 0. And for acceleration, we have negative 9.81 meter per second squared. And for our displacement is negative 1,050 meter. Therefore, our initial velocity, our final y component velocity is 143.53 meter per second. So using this data information we have for Vy and Vx, we can solve now for the final magnitude using Pythagorean theorem, which is equal to square root of Vx squared plus Vy squared. So substitute the value, then we can solve for V, which is equal now to 183.92 meter per seconds. And to solve for theta, use trigonometric function arctangent equal times arctangent, then the ratio of Vy over Vx, which is equal to 51.30 degrees. By the way, we have to check our Vy again, because as we can see in the illustration, By is directed downward. Therefore, its direction, it should have a negative value. Okay, so since we are square root both side this line, and the result square root, and the result for square root, as discussed in algebra, is positive, negative. Okay? Therefore, we have to consider the negative value for By. Why? Again, as illustrated in our figure, Vy is directed downward. Therefore, our final velocity must be negative in y direction. Okay po? Therefore, our theta should be negative 51.3. The angle between the x component and the resultant vector. Okay, so let's have another example. A baseball player hits a home run and the ball lands in the left field sits 7.5 meters above the point at which it was hit. It lands with a velocity of 36 meters per second at an angle of 28 degrees below the horizontal. So the positive directions are upward and the right is in the drawing. Ignoring air resistance, let's find the magnitude and direction of the initial velocity with which the ball leaves the bat. Okay, so we have here the illustration. We are looking for the initial value of the velocity. Also, okay, so our given are here the final velocity of 36 meters per second at an angle of 28 degrees, and final position in y component is 7.5 meter. To solve this, let's get first the component of the final velocity. So let's look for Vx and Vy. So for Vx, using the trigonometric identities, Vx is equal to 31.79 meter per second. For Vy, we use sine. Therefore, Vy is equal to negative 17.37 meter per second. Okay, so we have here now the values. for the component of final velocity. So next step, let's solve now for the initial component of the velocity. So let's go first for b naught y. To solve this, let's use the equation by squared is equal to b naught y squared plus 2ay times y minus y naught. And let's substitute the values. So we have negative 17.37 squared equal to b naught y, which our the missing value, times plus 2 times acceleration is negative 9.81 and y is 7.5 meter, then y naught is 0. And solving this, we can get the initial y component of the velocity is 21.19 meter per second. Okay, so for v naught x, so the value for v naught x is equal to vx, which is equal to 31.79 meter per second. Again, we have zero acceleration in x or horizontal motion, therefore there's no changes in the x component. Therefore, we can solve now for the velocity, the magnitude of velocity, using the Pythagorean theorem of vx squared, square root of vx squared plus by squared. Therefore, v is equal to, by substituting the value of the components, we can get 38.20 meter per second. Okay, and for theta, using arctangent by over vx, our theta is equal to 33.69 degrees. So this is our final answer. Okay, so let's check your understanding by solving this problem, these two problems, and comment your answer in the comment section below.